This is the topic for aggregates. Aggregate is one important ingredient in concrete mix, and aggregates are divided into two types of aggregates. We have coarse aggregates and another one is fine aggregates. It's very easy to identify these aggregates. The aggregates that retain in 5 mm sieving, that is what we call as coarse aggregate, and the aggregate that pass 5 mm, that is what we call as fine aggregates. And this picture suggests the example of both aggregates. This one is from crushed rock, quartz, pea gravel, and granite. And those fine aggregates, all of that we know as sand. And the pictures or the example shows different color of aggregates, fine aggregate, because the crushed rock is from different crushed rock. So what actually aggregate? Aggregate is the ingredient in concrete mix. It is the solid material which play no part in the chemical reaction. And for aggregate, it comes from gravel, crushed stone, sand, and etc. If we have 100% volume of air concrete, the 75% volume is come from aggregates. And you must be careful to select aggregate because we do not want any constituent material that might adversely affect the hardening of cement or durability of hardened mass. And the reduction of the volume changes resulting from setting and hardening the concrete. Okay, how to process the aggregate from the quarry? It's very easy to get aggregates. It is from three processes. Number one is to crush the rock into the size that we need. Second is to screen, and the last one is to wash the rock. The crushing is the process to break the rock into different size, but if you get source from natural, some sand and gravel does not require crushing. And for screening, it is to sort the aggregate by size. The screen look like window screen with opening that vary in size. Why we need to wash the aggregate before use it in the construction? It is to remove unwanted clay, dirt, and smaller size particle from the aggregates. For classification, we have the general classification of aggregates. Number one is normal density aggregates. Number two is lightweight aggregates. And the last one is high density aggregates. The list under normal density aggregates include crushed rock, sand and gravel, and also broken bricks. And for lightweight aggregates, we have expanded clay, pumice, and expanded shale. And the last one is high density aggregates is from the mineral rock of magnetite, hematites, and limonites. So all of these aggregate can be differentiated in terms of the density. And for normal density aggregates, the bulk density is between from 1,400 to 1,700 kilogram per meter cubic. And how to grade all of this aggregate is using Malaysian Standard 29 1995. And according to Malaysian Standard, the coarse aggregate more than 5 mm, fine aggregate is less than 5 mm. All in aggregate means that the mix of coarse aggregate and fine aggregates. So for coarse aggregates, it can also known by three types of aggregates, which is uncrushed gravel, crushed gravel, and partially crushed gravel. For uncrushed gravel, it is what you can get in the environment or in the site, which is natural disintegration of rock that eroded naturally, and all that rock is in the same size. We are using that without any crushing to any crushing before we use it to construction. And for crushed gravel, it is a crushing hard stone and gravel respectively. For partially crushed gravel, it is blending crushed and uncrushed gravel. For fine aggregates, okay, it is defined as high portion of particle passing a 5 mm sieve. And what come naturally is sand, okay, and this is from the natural disintegration of rock. You might get sand from riverbank and the like. And also from crushed stone sand or crushed gravel from the quarry. And this is sun crushing hard stone or natural gravel respectively. For all in aggregates, it is composed of mixture of coarse and fine aggregates. It is normally not graded and used in unimportant work as they are taken from the pit or riverbed, and also referred as pit run aggregates. So for lightweight aggregates, the function to have this is to make the concrete mix lighter, and also identify in terms of the density. So for lightweight aggregates, the dry density is around less than 200 kilogram per meter cubic, and for bulk density is less than 1200 kilogram per meter cubic. Okay, often comes from manufacturing, for example expanded clay or expanded shale, but it also can be natural rock, for example pumice. The unique characteristic of this lightweight aggregate is low density, high water absorption, but in terms of using it, you must mix with water before using it. It produces coarse surface texture, can reduce workability, lower tensile strength, and lower modulus of elasticity, and have the high creep and shrinkage characteristic. So next is the group of lightweight aggregates. It can come naturally from minerals. What types of natural occurring materials, including pumice, foam lava, volcanic tuff, porous limestone. And also from natural occurring material which require further processing, which is manufactured in uh, in factory. Some of that is expanded clay, shale, and slate, and other expanded minerals such as perlite and vermiculite. So the last is the material which occur as industry byproduct. For example, sintered pulverized fuel ash, sintered shale and colliery waste, foam and or expanded blast furnace slag. This is byproduct from factory. So for high density of aggregates, again the specification is from the unit weight and dry density. The specific gravity is around 2.8 to 2.9, and unit weight is 2800 to 2900 kilogram per meter cube. And it produces dense and crack-free concrete, not suitably graded, difficult to have adequately workability without segregation due to not suitable graded. The compressive strength is very high, is 20 to 21 Newton per mm squared. And for this kind of aggregate use, need to cement aggregate ratio varies from 1.5 to 1 to 9 ratios of cement aggregate ratio. So that is for the first type of aggregates. We will continue for the next discussion.